For this video, we're going to be discussing simplifying square roots. So before we talk about simplifying, let's make sure we understand what a square root is. We're going to do that by starting by talking about squaring a number. So squaring a number means multiplying that number by itself. So for example, if I did 8 squared, that's the same thing as 8 times 8, which is 64. Taking the square root of a number is simply the opposite of squaring that number. So if I did the square root of 64, that gets me 8. The symbol for a square root is also known as a radical. So this symbol right here is known as a radical. And then we have special square roots. A number whose square root is an integer is known as a perfect square. So that means when I take the square root and I just get a nice round number that is not a decimal, that's called a perfect square. So here I've got the first 20 perfect squares. And these 20 perfect squares are all of the perfect squares that I think you should probably memorize. It won't hurt you not to memorize them, but it'll make everything way easier if you do memorize the first 20 perfect squares. So those are 1, 4, oh, this is being weird. 9, 16, 25, 36, 49, 64, 81, and so on up to 400, because the square root of 400 is 20. If you look at this list, all of the perfect squares that we're going to be dealing with today are going to use at least one of these perfect squares. Now there's a lot more perfect squares. There's an infinite number of perfect squares. And you can always tell if a number is a perfect square by just using a calculator to do the square root. Say I want to know what if say 600 is a perfect square. I just put in 600, take the square root, I get a decimal, 24.49, whatever. That means this is not a perfect square because it's a decimal. For today, we don't want to deal with any decimals whatsoever. So if a number is not a perfect square, it can be simplified. And the way we simplify is by finding perfect square factors of that number and then taking the square root of those perfect squares. So for example, if I look at 8, I know 8 is not a perfect square. So I want to try and think of numbers that are factors of 8 that are perfect squares. So I'm just going to think of the factors of 8. 8 is 1 times 8. It's 2 times 4. It's not 3 times anything. And it's 4 times 2, which I already have. So these are all my factors of 8. Now 1 is a perfect square, but it's not really helpful to us here. 4 is a perfect square, and that's the one I'm going to use. So what I'm going to do is I'm going to separate 8 into the square root of 4 times the square root of 2. Got to keep the square roots on both of these. Take the square root of 4, that's 2. And then I'm just going to bring down the square root of 2. And that's my simplified radical, 2 square root 2. So our procedure is to first check to see if the number is a perfect square. You can look at your list of the first 20, but if it's a very large number, you might want to just use a calculator. And then if it is not a perfect square, I want to find a factor of that number that is a perfect square and separate your number into the perfect square and its factor partner. I'm going to simplify the perfect square by taking the square root and just leave the other number in the radical. And then my last step is to check to make sure that that number that I left inside the radical doesn't have any perfect square factors itself. And if it does, I just got to do this process over again. So let's take a look at some examples. So here I've got the square root of 80. So if I look at the square root of 80, and I try and think of factors of 80. So 80 is 1 times 80. It is 2 times 40. 3 doesn't go into it. It's 4 times 20. It's 5 times 16. Oh, and 16 I know is a perfect square. So I'm going to look at 80. I know it's not a perfect square. I found the perfect square factor, so I'm going to separate it out. Square root of 16 times the square root of 5. Now I want to take the square root of 16, which is 4, and I'm just going to leave this other factor underneath the radical, 4 times 5. And then step 4 is to check to make sure this number doesn't have any perfect square factors. So the factors of 5 are 1 and 5, and that's it. There are no other factors of 5. 1 is a perfect square, but we don't really use it for this process because square root of 1 is just 1. 5 is not a perfect square. 5 doesn't have any perfect square factors, so 4 root 5 is my answer. Let's take a look at another example. So here I've got 1,200, square root of 1,280. First thing I want to do is see if this is a perfect square. I don't know, that number's big. It's bigger than anything that's on my first 20 perfect squares. So I'm going to pull up a calculator, put in 1,280, find the square root, 35.77. It's a decimal, it's not a perfect square. Okay, so I got to simplify this. So I'm going to take a look at this number, and I'm going to think, what's a perfect square that I think might go into 1,280? Well, I know 4 goes into 1,280. And if I do 1,280 divided by 4, I'm going to get 320. Okay. So if I do the square root of 4, that's 2. So I get 2 times the root of 320. But now I need to check, are there any perfect squares that go into 320? Well, 320 is, well, I know 16 goes into 32, which means 16 also has to go into 320. So this is going to be the square root of, if I do 320 divided by 16, I get 20. So this is the square root of 16 times the square root of 20. Bring down this 2. The square root of 16 is 4. So this is 2 times 4 times the square root of 20. All right, I got to look at that 20. Yeah, there's a perfect square that goes into 20. 20 is 4 times 5. Square root of 4 is 2 again, so I got 2 times 4 times 2 times the square root of 5. And then if I work that out, 2 times 4 is 8, times 2 is 16, so this is 16 root 5. All right, and that's my answer. That was a whole lot of work that I could have done a lot easier. I found the smallest perfect square that goes into 1,280. My life would have been a whole lot easier if I found the biggest perfect square that goes into 1,280. So I'm going to try this a different way just to show you. So 1,280, I'm going to start by dividing small numbers from this. So 1,280 is 1 times 1,280. It is 2 times 640. It's not divisible by 3. If I do 1,280 divided by 4, I get 320. So far, none of these that I've found are perfect squares except for 4, which is pretty small. We saw all the work that happened with 4. If I do 1,280 divided by 5, that's 256. And 256 is a perfect square. It's a really big perfect square. So if I do my work over again, and I split 1,280 into the square root of 256 times the square root of 5, the square root of 256 is 16. And then I can bring down my square root 5. Notice I got the same answer with a whole lot less work. So if you can find the biggest perfect square that goes into a number, it makes simplifying a whole lot easier. Here's example 3, square root of 21. Okay, if you look at your list of perfect squares, you'll see that 21 is not on there. Square root of 21 is going to be like 4 point something. So it's not a perfect square. So if I think of the factors of 21, that's 1 times 21. 2 doesn't go into 21. It's 3 times 7. 4 doesn't go into 21. 5 doesn't go into 21. 6 doesn't go into 21. 7, well, that's 7 times 3, but I already have 7 times 3. So here are all of the factors of 21. Okay, 1's a perfect square, but we don't count it. 21's not a perfect square. 3's not a perfect square. 7's not a perfect square. 21 doesn't have any perfect square factors. So, my answer, my most simplified version, is just square root of 21. I don't do anything to this problem. It's going to be like that sometimes. Some numbers don't have perfect square factors, and because of that, they can't be simplified. So, I'm going to leave you with a try it problem. Simplify the square root of 192.